So, hello and welcome everyone who spent time to attend this session and ensure that they are up for what is there in store for them. So, let's start the session. It is said that information is the oil of the 21st century and analytics is the combustion engine. This is said by Peter Sondergaard. He was the former global research head at Gartner. Today, we are here to discuss career paths in business analytics. Business analytics means taking in and processing historical business data, analyzing that data to identify trends, patterns, and root causes. Making data driven business decisions based on those insights is opening a lot of career opportunities, and that is why we are here. Today, in this particular session, there are going to be certain questions which are going to be answered, and definitely we'll be taking questions from your as well. Some of the topics that we'll be covering is why data science and data analytics is the key to success of any business, career growth and prospects of data scientists as a career. What are the applications of data science in marketing, finance, supply chain across the sectors? And what are the key requirements that you need to have to pursue a career in data science? To give us the information about all these topics and all these uh, key takeaways, we have with us Professor Dr. Tuhin Chattopadhyay from Jagdish School of Management. Dr. Tuhin is the founder and CEO of Tuhin AI Advisory and a celebrated technology thought leader among both the academic and the corporate fraternity. He is a recipient of numerous prestigious awards. Dr. Tuhin is hailed as India's top 10 data scientists by Analytics India magazine. His guidance and thoughts will be a great learning opportunity for all of us. Let's know a bit about Jagdish Sheth School of Management. It was formerly known as IFIM Business School. It is a business school in Bangalore and Greater Mumbai. Founded in 1995, Jagdish Sheth School of Management offers PGDM, MBA, BBA, and PGDM executive programs. Jagdish Sheth School of Management is amongst the first six business schools in India to have been awarded the AACSB accreditation and QS ranked institution in India. So I hand it over to you, Dr. Tuhin. I'm sure students are eager to listen from you.
Absolutely. Thank you so much, Chintan. I deeply appreciate your kind introduction of me and our institute. Before diving deep into the career part, I believe it's very critical, especially for the folks who have got very little to no exposure towards analytics. It's very important and critical for them to understand what analytics is, what data science is, before we jump to the career prospects and the growth opportunities. We will come there, we will slowly shift our gear. But before that, it's let's explore what data science is, what analytics is. You must be all knowing that the most critical part of management education is taking decisions. I would have asked the question, but then I could have asked the question that what is the most critical part. But I shall take the questions in the last 20 minutes. But I would request you to simultaneously think with me, even if you can't ask the question. Let's be a kind of interactive in the sense that we co-think, we think together. So the most critical part, as you can understand and appreciate, and that's the reasons the management professionals are highly paid, highly appreciated, highly regarded, because of the decisions they take that take the organizations to huge growth, to the, I shouldn't even say the sky, because even sky is not the limit in that way. So but the question that obviously comes is that how the organizations take the decisions. That's the most important part. How do the organizations take decisions? Gone are those days when a senior management professionals or the senior vice presidents will come and say that, yeah, for the last 20 years, I have seen things move in that particular way, so we should do like that. No, it doesn't happen like that. We apply mathematical tools, techniques, statistical tools, techniques, all the different branches of mathematics, not only mathematics and statistics, operations research, calculus, multiple matrix algebra for that matter, again, a very critical tool. we apply multiple tools and techniques that helps us to take decisions. So that's why the recent name, we just don't restrict ourselves to call the field as data science or analytics only. We also call it decision science. So that means what? That means there is a science, there is a way. There is a way to take decisions. You cannot just take decisions based on your gut feelings. You cannot just do some simple Excel-based calculations and take decisions. There is a science to take decision. It is very important for everyone, and especially for management professionals, to learn how to take decisions. So that's what analytics is all about. That's what data science is all about. That's what decision science is all about. If there are any questions so far, you can keep a note of it. At 6:40, I shall take these questions. So that's what I covered, that why data science or decision science important. Now, the next thing, what obviously comes, that what kind of decisions? What are those type of decisions? Broadly, we can classify the decisions to 3 tiers or 3 rungs, or through 3 categories. The basic layer, I would say, the descriptive analytics. That means we will understand by the mathematical tools and techniques that what's happening in the market. Happening in the sense, say, the customer segmentation. Here, I'm not predicting anything. I'm not prescribing that what needs to be done, but I'm doing some segmentation based on, again, some statistical tools and techniques, or the company segmentation, or the market share of the companies, or the brand shares, where I'm just figuring out that, again, figuring out by applying the science, that what's happening in the market, what is happening in the business. So that's the descriptive analytics part. The next higher layer, or the next higher tier, is the predictive analytics, where we forecast that what is going to happen. Again, in my next part, I'm going to give the examples, but let's understand the concept now. So what's going to happen, we are going to predict, we are going to forecast. So that's what the predictive analytics is all about. And the third one, or the ultimate goal or ultimate layer of analytics, is the prescriptive analytics, where we not only predict, but also we prescribe the clear pathways that what needs to be done. So that's the prescriptive analytics part. And obviously, before I give the examples, obviously you need to understand that there are multiple tools and techniques. When I'm saying science, of course, the science is the conceptual or the mathematical aspects. But then to implement that science, there are multiple tools and techniques. Now, what do I mean by the tools and techniques? The tools are the algorithms. The tools are the multiple algorithms that we apply. So for predictive analytics, we have got multiple statistical algorithms. The most basic is the regression. That, again, the various types of regressions. There are various types of classification techniques, not only the predictive part. So there are multiple tools. Sorry, there are multiple techniques. And then what are the tools? So techniques are the algorithms, and what are the tools? Tools are the different types of software, different types of languages. So why I've taken a pause? Because there's a big difference. So again, in our times when we started our career, there are all the software like SAS, SPSS, Statistica. Many of the softwares were there which were used to implement the algorithms. But now it's an area of open source. So R, Python, Spark, Scala. So much open source language where, one need not pay the licensing fee. So you can apply the languages and generate the business insights. So that's what the open source languages are. So all these tools and techniques are implemented for taking the decisions, for the decision science. So, and all these tools and techniques are implemented across the three layers, the descriptive, predictive, prescriptive part that I mentioned. Now, coming back to the examples of this descriptive, predictive, and prescriptive, what are the examples? Say, for instance, the descriptive analytics. I would like to know how the brands are positioned. Position means what the people think about the brands. So there are techniques, there are algorithms. There are algorithms for it. It is not that I shall think that what they might feel about our brand. It doesn't happen like that. There are multiple techniques to figure out that how many dimensions are there in my brain. What kind of dimensions? Say the most popular are the price and quality. So say if I take for the sake of simplicity only two dimensions in the multidimensional space of our brain, how the different brands are positioned in that brain. We can exactly create a kind of graph and figure out the descriptive analytics that how the brands are positioned. And if we feel that the brand is not being positioned rightly, we can again reposition it. Many of the brands have done it, you must be knowing already. Or we can do the kind of customer segmentation. So a company might have multiple customers, crores, millions of customers, but then based on the homogeneous characteristics, based on some characteristics, I can figure out that how these customers can be grouped together, how the customers can be grouped by a few characters. It can be demographic characteristics like age, gender, income, geography, or can be their transactional characteristics. If I'm working in a bank, like what are their kind of whether they have defaulted or not, what kind of loans they have taken, what are the general tenures, what is the amount of loan, what is the frequency of taking the loans, what are the different types of loans for that matter. So it's up to us to figure out the variables and then we can classify. So that's exactly the realm of descriptive analytics, what I'm describing, but I'm neither predicting or prescribing. Now coming to the realm of predictive analytics, again, a very important part, because you can precisely means to the extent of 97 to 99% accuracy, you can forecast that what's going to happen in future. And that can happen across the sectors, as well as across the different functional areas of business. What are the functional areas of business? Like marketing, like finance, like supply chain, like the systems and networking. So this can be across the functional areas and the sectors. So for instance, let me start with marketing. The most important part of marketing is the what? The sales. The sales. Now the sales depends on so many variables. Sales depends on hundreds of variables for that matter. It can be price, it can be the promotion. Promotions can be again the different types of promotions, starting from the investments in traditional media, like TV, newspaper, radio, or the digital media like the Google ads, YouTube ads. YouTube ads can be different types like skippable, non-skippable, ads in the different social media, Facebook, Insta, LinkedIn. And so what is the exact impact of each of these variables in my language, or if you are not comfortable with that word variable, what is the exact impact of the price, the different types of distributions, the different types of promotions on sales? So that's the classic application of analytics or the predictive analytics on marketing. Or for example, if I move to supply chain, the demand forecasting, again, the mother, I would say the mother, whatever the problems, whatever the business problems or the analytics problems that you can consider for supply chain, like the demand forecasting, or you can say the inventory analytics or inventory management or inventory optimization for that matter. You can talk about the network planning or the distribution planning, where you will have the distribution centers. Or if you think about the replenishment analytics, how frequently and how much will you replenish Or if you can think of the transportation analytics, what should be the right modes of transportation, what will be the right mix of the transportations, everything will go for a toss if the demand is not being forecasted rightly. So that's the mother. Now, how will you do the demand forecasting? Again by the statistical mathematical tools and techniques. So again, if you move to finance, everything, starting from the stock price prediction or the company, suppose a merger acquisition is going to take place, how successful will that be in future? Or if I just look at the kind of the same finance with the customers, the very critical model is the credit score model, like whether I shall issue a credit card or give a loan to a customer or not. And if I give a loan or if I issue a credit card, how much? What should be the right limit for a customer? Everything we do it by our model. This is all about we take decisions, this kind of decisions we take by applying the modeling techniques. Or if I go to the systems or networking. So what is must have seen, you must have experienced, you must have also heard that there are multiple failures of the servers. So I can predict that when a server can fail. If I know that what are the different components on which it is dependent, I can precisely predict, hey, the probability of failure of your server is this much on this particular day. Or again, if I come back to say the customer, I can pretty well figure out that what is the probability of a purchase, what is the probability of a purchase of a customer, given all the customers' past transaction variables, the demographic variables. So you can pretty well figure out, hey, whether I shall pursue this customer or not. When you can pursue, if a customer's probability of purchase is say more than 90%, then you need not pursue, right? Again, if it is below say 50%, 40%, if you pursue, that might be a waste. Probability is high, that may be a waste of money because the customer is not interested. Now you can classify your promotional discounts based on the probability of purchase. If the probability of purchase is between 80 to 90%, maybe the promotion need not be that high. If the probability is between 70 to 80, it should be slightly higher so that the customer gets attracted, gets excited. If the probability of purchase between 60 to 70, it will be further higher to ensure that a customer must purchase. So that's how you can get a sense. I'm sure now you can get a sense that how at every step analytics is required, data science is required, decision science is required. And before I go to prescriptive analytics, let me tell you, I'm giving you the business examples. Doesn't mean that this analytics or data science or decision science is restricted to business only. Whatever is your area of interest, it can be sports, it can be arts, like figuring out the price of an art piece, artwork. It can be wine, because you must be knowing that's also a good investment these days, keeping the bottles of wine. So what should be the price if I keep it for 12 years, 15 years, 18 years, 25 years? So everywhere, whatever you do, business, non-business, you have to take decisions continuously. And then that science is there. And the science is there which will help you to take the decisions. Now coming to the last rung or the third tier is the prescriptive analytics. So number of examples can be given. So one classic example of marketing is the marketing budget optimization. Like how much money should I spend on each of the advertising avenues, advertising channels? Now you all know that advertisement and sales doesn't go with a kind of steep curve. Like if you keep investing money, sales will keep going. It doesn't happen like that. It always takes a kind of, it starts increasing and then it starts increasing at a decreasing rate and then the curve flattens. So what exactly is the point beyond which even if you keep investing the money, the sales will not go up? So that becomes the constraints of your optimization models, where you need to maximize the sales given certain constraints. Constraints are the inflection points for each of these advertising channels. And once the problem, business problem is ready, then our mathematical tools or the operation research tools or the optimization tools can clearly tell you that how much money you need to spend on each of these advertising channels, advertising revenues. So that's a classic example in marketing. If I move to, say, finance, the application of prescriptive analytics in finance. Say if you were a manager of a mutual fund. So what is a mutual fund? It comprises of multiple stocks that we all know. Now, that's not the point. Point is that what stock should I have? Number one, suppose you identified again, 5 stocks or 10 stocks. First of all, there is a science to identify the stocks. But most important part after that is that what is the proportion of each of those stocks in that particular portfolio? Should it be 5% each of the? It need not be the same. It should not only need not be, it should not be the same. It depends on so many factors, like what is the return, what is the risk of each of the stocks. So that becomes our constraints in the model. And then we want to maximize our entire portfolio's return. So our mathematical tools can tell you that whether one stock will be 13%, and there will be 17%, and there will be 7%, and there will be 5%, and there will be 21%. So that's the kind of optimization where we can precisely prescribe that what should be the right proportion. So that's the applications across marketing and finance. Now, if you look across any, so I guess these 3 tiers are clear conceptually, as well as the applications across the marketing, finance, supply chain, and systems. So I hope this is clear. So what I have done, again, I'm repeating, I clarified first what is data science and decision science, then the 3 tiers, and then with examples across the sectors. Now, the next part, across sectors is across the functional areas of business, like marketing, finance, supply chain, systems. Now, you can think of any sectors. You can think of any sectors you want. It can be pharmaceutical to as diverse as, say, aviation has got no relationship, or you can take FMCG to shipping. Wherever you go, any sector, every sector is driven. Every sector's every decision is being driven by these analytics. Without this data science engine, they cannot take any. Let me give you a few examples. It will be clear to you. Once SpiceJet was my client, and then they gave me a problem like, hey, Tuhin, we need to reduce our cost once the restructuring of the organization was taking place. So that's the kind of business problem. And then how you need to convert that to a kind of analytics problem, because organizations or your clients as a consultant might not know what is it's 6:28. So last 10 minutes, 6:30 to 6:40, I shall move to the devote to the career tab. But let me give a few examples across the sectors. It will be clear to you. So after doing a lot of consultancy, I understood that consultancy means visited the client's office, interviewing the pilots, the air hostesses, the ground staffs, the office admin. That fuel is the most critical part. More than 50% of those things happens in more than 50% of the cost is driven by the fuel. So what exactly are those variables which are leaving an impact on the fuel part? Developed a model, applied the model, and then revenue got stopped. Worked in Southeast Asia with a bank in the early stage of my career. I was there in the bank, and then developed their customer segmentation and customer propensity models, where they have got, again, millions of customers based on all the profiles like loans they have taken, based on their banking history, group the customers so that is very important. Why I'm doing that thing? That's a very important, because it is business analytics. Mind it, it's not a fancy. Just because you can do mathematics, you shall not do mathematics. It should serve a business purpose. Now, coming back to the answer of so that the right promotions are given to the right segment. That's a very critical part, because one size doesn't fit all, right? So you have to figure out that what needs to be given to which segment. So that's the reason segmentation has been done, And then we figured out what kind of promotion needs to be given to each other segments. So for the shipping analytics, for example, Great Eastern Shipping was my client. And then figuring out that there was a problem in the machines of the ships, that what exactly was the kind of, triggering the problem in the machines, and what is the probability of failure of the machines, that we figured out. So across sectors, even in pharmaceutical, as I gave the example, pharmacovigilance, like figuring out that what are the side reactions of the drugs can be figured out in an automated way from the research papers through NLP, natural language processing algorithms. So any sector, any business function, analytics is the tool and technique, is in capital, is the, I would say, the in capital, tool and technique to take the decisions. So we are 6:31, last 10 minutes. I shall discuss on two things: what it requires to be analytics professional, and number two is that what are the career prospects. Let me start with the career prospects first, and then last part is because that's the most interesting thing, I guess, that you must all be thinking that, yeah, am I an analytics guy? Am I an analytics or data scientist material? So first, let's start with what are the career prospects. Again, the sexiest job, that's not my word, it has been quote unquote, sexiest job of the century is data scientist. So there is no doubt, I need not say it, I'm sure you all know, the most sought after career path in today's world, in the industry, is data scientist, where you are supposed to analyze the data and take the business decisions, generate business insights that would help the organizations move forward. So across industries, across sectors, always there are opportunities. There are opportunities both in the in-house analytics teams of the organizations. Say, for example, Amazon has their own team, analytics data science team, or there are standalone analytics organizations like New Sigma in India, or the Fractal, or the different leading guys of the world. The third part are all the big consultants, the BCG, McKinsey, anyone you name. Everywhere there is a huge, massive demand of the data science professionals. I would say the good data science professionals, not anyone. That's very important. You have to be a real data scientist. That's a very important part. Now I shall move to what is required. What's required to be a data scientist? Because that's the kind of question I frequently been asked to me, especially for folks like you who are in a dilemma to pursue a career analytics or not. Questions like, should I have a kind of mathematics background? Should I have a kind of computer science background? I would say that what is most important to be successful in this field is your conceptual clarity. If you can know how to think, then you can take up these things. Even if you don't have a mathematics background, if you don't have a computer science background, see, coding is no big deal. Especially, we are not in the era of Java or C++, when in our times it was pretty difficult. I started my life with C, then moved to C++, then Java. Things are pretty smooth these days. Python is like, you all know, I'm sure you all know Python. It's like, coding in English language. So I'm not here at all. I'm not preaching at all that you have to be a coder to be a data scientist. No, that's not the point. Point here is that, can you think independently? If you can think independently, putting that logic into a language that computer understands is no big deal. That's a translation of your thought process. But what is important is your thought process, independent thinking. That's the most required. Do you require a mathematics background? It is always good to. It is always good to have a mathematics background. But having said that, you have to also understand that nowadays we outsource or delegate the entire computation part to software. In our times, we do pages after pages mathematics. In our times, we didn't start our career with the software. we had to do every problem by hand. But gone are those days. Now I have to formulate the problem, give it to the software will solve it for me. But there is a big catch. There's a catch is that GIGO. You know, GIGO means garbage in, garbage out. So if you don't formulate the problem right, if you just give some messy data, random data, then obviously garbage in and garbage out will come out. So you have to be, again, the most important part is that ask yourself, do you love data? Because this conceptual clarity will not happen with any other thing in this world. Of course, any other things will help in the, if you have conceptual clarity, it will help in the other things of life. But then here you have to work with the data. First and foremost, are you passionate about data? Do you love numbers? Can you recognize pattern out of abstract reality? So there are a lot of numbers, lot of messy reality, abstract reality around you. Can you find out a pattern around it? If those things interest you, if you have a natural acumen, if you love numbers and taking decisions based on facts and figures and numbers, this is the subject for you. This is the area for you. Mathematics, programming are just the tools, and techniques to implement it. But then one should not focus on the implementation tool. The first focus should be on the conceptual tool. If you feel that, yes, I love numbers, yes, I'm a thinking guy, I can think real deep, I can really see through the things, I have got that insight, I have got, more importantly, the acumen. More importantly, I've got the aptitude and acumen to see through the things. And then I can apply the science and the programming tools on the top of that. Then data science, decision science, analytics is for you. I hope I'm clear. So yeah, last 20 minutes, let's take questions. Chintan, I leave it to you. You can ask the questions or let the participants ask the questions. Over to you, Chintan, so that I can take it forward.
Yes, sir. Sure, sure, sir. So the students have already shared a few questions. I'll just go through the list and you can take it one at a time.
Sure.
Does that work, sir?
Sure, absolutely. If it would be great if you also name the students, because I can understand. Yeah. And the students can also ask the question if they want. They can unmute themselves and they can ask. If it is fine with you, Chintan.
Yeah, like either ways, but I guess
you start it.
The questions are anyway in. So
yeah, absolutely.
So Aditi has a question that what is the scope in business analytics at the undergraduate level?
Well, if you look at the industry perspective, if I have to hire someone, I shouldn't go by the degree. Undergraduate, postgraduate, doctorate, postdoctorate, higher secondary, that is not the right parameter here. Parameter is very simple. Can you do the work or not? Nothing else counts, honestly. Of course, I'm not saying that any class 8 pass will come out, because they cannot have that skill. But then the point is that there can be a voluntary dropout from the college. I'm just saying. I'm not promoting you to be a dropout. That's not the point. But the point here is that focus not on the undergraduate, postgraduate. Focus on the tools, techniques, understand them, and then show your skills to the world. How to show your skills, the obvious corollary or the obvious question. Join the hackathons, multiple data science competitions going around the world. I'm the judge of many such data science competitions. Join Kaggle, show your score. Kaggle is a platform of data science competitions where the folks around the globe come there. Open your GitHub account. GitHub account is the platform where you can create the repository of your codes, show your codes to the world. Now, if you have some very sophisticated codes, if you have got a high score in Kaggle, what do I mean by that? If you can really solve some big problems of the world, then whether you are undergraduate, postgraduate, that doesn't matter. What matters is that do you have the right skills or not? Do you know the subject? Can you solve the problem or not? and your solution can generate revenue, can reduce the cost for the company or not. Now, if I have to, now these two things could not separate it. If I have to bring some, if I have to bridge these two things, yes, at undergraduate level, certain skills being taught, at postgraduate level, also certain skills being taught. So I would say it's a journey. It's a journey of your analytics or your journey of your learning analytics. So on board, embark the journey, get yourself onboarded to a journey, keep learning, keep implementing, keep sharing to the world what you have achieved. Sky is the limit.
Right. So you mentioned that the students can take part in hackathons, they can go to Kaggle. But like something that I've noticed over time is that like we live in a society where marks, where certifications and everything is given a lot of weightage, and it's also given a lot of preference. So in such cases, are there institutes, are there companies which are actually focusing more on the practical aspects or the application based aspects rather than just the certifications and everything that they have on a piece of paper?
See, again, these two things go hand in hand. These two things go hand in hand. How do they go? How do this thing go hand in hand? I find very few persons in this world who are self-learned, to be very honest. That means what? 99% of the people have learned from some places. Now, these some places can obviously be categorized, can be classified. What do I mean by that? There are real good places, there are real mediocres, and there are real not so good places. Now, if you are taking a certificate, if you are my student at JAXAM or in some real good places, obviously that will be value. If you say that I learned from Dr. Tuhin, people in the industry know that who Dr. Tuhin is, and then if you are his student, that's been regarded. So when I'm saying that piece of paper is not the only thing, when I'm saying that your real solution development matters, but it's also very important that where from you have learned those skills. So from that perspective, that certification, the marks matter.
Okay.
You cannot say that, I took a course in analytics, but I got only 40% and then also I'm great. That doesn't create the story. That doesn't make much sense.
Right.
Or I am an analytics professional, but I have done a kind of 3 months course in any mushrooming institute, 3 months programming or coding course. It doesn't add up to. One has to go through a thorough journey. That's what I'm saying. Undergraduate, postgraduate, take your journey, take the voyage. And then automatically you will keep learning, keep implementing. That's how the experience will come. Learning experience will inherit.
Right. So I'm glad you mentioned that, because Rohit has a question on a similar line. So he says, what are the technical skills that are required to firstly learn and then eventually build a career in business analytics?
See, technical skills, first of all, I don't know, Rohit, what's your background, but if you don't have a CS background, don't get scared. Because that's the question I always said, I don't have a computer science background. Is it my cup of tea or is it my glass of wine? Don't worry, it's fine. Nobody is born computer scientist. You can always take up those skills if you have that talent, which you have, which you all have. That's why you have taken this journey. That passion you have. That's why you are in this webinar. Otherwise, you would not have been. So if the passion is that, you can always take up those skills. Now, what kind of technical skills you require? Obviously, you require the coding skills. Goes without saying. Obviously, you require a good understanding of mathematics, statistics. How do they operate? Because you have to work with numbers at the end of the day. It is not a kind of lip service English.
Right.
It's not a kind of sales job that, you have to do a kind of sales by speaking. You have to actually be hands-on. That's very important. You have to put your fingers on your money, on your keyboard, analyze the data, spend days, nights, burn the midnight oil with the data and generate the insight. So technical skills, yes, coding skills, yes, mathematical skills, but don't get scared if you don't have them. You can pick up all those things if you have a passion. I think the most important thing is not the technical skill. Most important thing is the passion, that zeal, that fire in the belly. If that is there, then nothing is a constraint, I would say.
Right. So Aditi has a follow-up question. So she says, in the current scenario, is there more weightage for softwares like SAS Enterprise or open sources like Orange or Jupyter?
Well, as I mentioned, that the world is slowly but steadily moving from the licensed software to the open source era. Obviously, it is obvious. Suppose if I can get a kind of free tool, open source will not pay. Why am I going to pay the licensing fees to the software? So naturally, world is slowly but steadily moving. So I have a suggestion here, which I keep giving to my friends. Don't get married to one language or software, because I have seen in my career the birth and demise of so many softwares, so many languages. So in our time, it was SPSS, then SAS, and then it was R, Python. But you know what is constant? Constant is that the algorithms have not changed. Yes, there are advancements to the basic algorithms. So regression has become more sophisticated than what it was. But then the core, the heart of those algorithms remain the same. So understand those algorithms, how do they work? If you have that conceptual clarity that how do the algorithms really work underneath, then implementing that thing through language A, B, C, D doesn't require a much varying scale. It requires slightly difference, but it's not a measured difference. But then it shouldn't be the approach that I learned R or I learned Python, therefore give me a data science job. That's wrong.
Right.
Python is only a tool to implement it. Tomorrow there will be some other tool. Day after tomorrow there will be some other tool. That's how I have seen it. That's how it happens. So understand the core techniques. Then there are tools to implement, and learning the tools is the easiest job.
Right. So Ashmeet has a question that he wants to take up business analytics as a major. But in that case, should he opt for dual specialization, or should he go for a subject which kind of works along with business analytics as a minor?
What do you mean by subjects which are going along with analytics? See, ultimately you have to understand analytics, or rather business analytics, doesn't work in vacuum. That's why it is called business analytics. It is not just mathematics. It is not just statistics. It is not just calculus, not just matrix algebra, or not just operational research. It is business analytics. That means analytics operates in the environment of business. Depending on your passion, would you like to, is marketing, do you like to solve the marketing problems? Then if you can take minor as marketing, and then marketing analytics would be your area. Or supply chain interests you, then you do the supply chain analytics. Or finance interests you, do the financial analytics. So analytics is the mathematics behind any of these fields, which will help you taking the decisions. Now, what is the area depending on your passion?
Right. Makes sense. So Amy has a question. She says that she's not able to solve CAT level DI questions right now. So can she expect that she'll also be good at data science, or like what should she consider? Because maybe I assume she's preparing for CAT as well. So she's not able to solve the data interpretation questions there. So will she be able to do it, and will she like her job as a data scientist?
See, if I have to comment about these CAT data interpretation questions are not that tough. Of course, there are multiple ways to crack it. One is that practice, and practice. If you keep practicing, you'll understand the patterns, you can crack it. That's one route. That's one route of cracking it. The other route, which is a more natural route, is that do you really love figuring out or recognizing the patterns in the messy data? If those things interest you, then you have the natural acumen. I would suggest take a pause, look within yourself, rather, I would say, introspect, see what you are naturally good at, pick up that skill, brush up that skill. You will excel like anything. Now, I cannot expect Sachin Tendulkar to sing and Lata Mangeshkar to play cricket. That doesn't happen in this world. But they could not be that successful had they taken some other professions. So take a pause, introspect, see what you are naturally good at. Take that one as your profession. You will excel like anything. Things are not difficult, but whether it is in sync with your passion or not, if this synchronization happens, then it will work like anything.
Right. Ananya and Geetika have a question. They want to know, is data analytics and business analytics same or different? And what is the job role of a business analyst?
Okay. So data analytics, business analytics, more or less the same, slightly different. Data analytics, when I'm saying I'm not confining the context. Data analytics can be in sports also. Data analytics can be in the different other fields, as I mentioned, can be in arts also, can be in any field, in whatever is your area. Business analytics is confined to taking business decisions. But yes, depending on the context also, context means the area or the field where you are going to take the decision, algorithms will of course change. The algorithms that we'll use for sports analytics, using sports also, what you will use for cricket and what you will use for football and what are you going to use for golf would be very different. So you have to understand in the sense, you have to first of all figure out the area also where you would like to apply these analytics tools and techniques, then learn the relevant tools and techniques, apply it. What was the next question? There are two questions. This was the first.
Yeah. So the second question was, what is the job role of a business analyst?
Okay, job role of business analyst. Analysts are not expected to do or not expected to solve very sophisticated data science problems. That is the most junior role. They are supposed to do some analysis of the data primarily in Excel, create some basic charts, but not the more sophisticated predictive analytics or the prescriptive analytics level things. So that's the primary or the basic job role of what you can expect in the industry.
Okay. Kajol wants to know, from where should one pursue post-graduation in business analytics? Should it be from India or from the US?
Well, you will be pleasantly surprised to learn. Not that you have to take my words. You can do your own research also. Folks like us only, Indians only, teach in all the leading B schools. My friends teach in leading B schools across the globe. I taught in number of B schools outside also. I train also, not only to the B schools, to the corporates also around the globe. As far as this subject area is concerned, analytics is concerned, Indians are ruling across the globe. So you can get Indian education at a much cheaper rate than what you're going to spend in US, unless you want to enjoy a package tour in US where you want to enjoy the vacation of 2 years, and that's a separate goal altogether. But as far as the education is concerned, Indian education analytics from the good institutes, I must give this caveat, not any institute, is definitely preferred.
Right. Geetesh wants to know, what are some good programs in India and all across the world to kind of switch his career and get into data science? So certain programs that you would want to suggest.
So in most of the scenarios, you will find that analytics is offered within MBA, and there is a reason to it. And the reason I already explained in a subtle way is that this analytics doesn't work in vacuum, doesn't work in isolation. What does that mean? If you don't have that business context, if you don't know how the business world operates, then you will have a hard time in getting aligned with the industry requirement or solving the industry or real life business problems. So it is very important that you pass an MBA program, and then you will understand the business from the different subjects that has been taught in the MBA, and data science analytics on the top of it. Then there is a perfect, matching or perfect marriage between the two things in your mind. Yes, this is what business is, this is what mathematics is. That's how they come together, and that's how the problems can be solved. Otherwise, if you just pursue data science course, then the mathematics part will be there, but then the entire business context will be missing. Then it will be a hard time.
Right. M. Venkatraman has a question. What is the functional difference between analysts and consultants in the supply chain area, in the sense that who's more valuable and their functionalities, their job roles?
Correct. Correct. So I think that would be the last but one question.
Yeah.
So in any role, not only in supply chain, in any area, one cannot jump to analyzing the data once you approach the client. It starts with business consultancy. So you have to understand the business problem first, then convert the business problem to analytics problem, in the sense that figuring out the right variables, because ultimately you work with the data and variables. So that's the consultancy part. Then the data science job comes in analyzing the data and generating the insight. Again, then the recommendation and the implementation recommendation comes. So that's the complete cycle. So this complete cycle will not be possible only by analyzing the data. It has to be started with the consultancy and has to be ended with the consultants. Consultancy, how to end? You have to handle the client implementation. You cannot just give lip service. Hey, these are the 5 recommendations and give me my remuneration. It doesn't happen like in today's world. So it has to be implemented. So yeah, consultancy is very well integrated bits, not only in supply chain. So anywhere, any field. In supply chain, say demand forecasting, if I have to say, you have to understand the variables in a particular industry, the way demand is there in a, say, Pizza Hut, and the way the demand is there in a kind of aviation or any kind of transportation for that matter, are very different. The variables are very different. So you have to, as a consultant, understand those things. What kind of variables triggers that particular problem? And then data scientists will come in the picture to analyze the data.
Right. So Somesh has a question. What are the core competencies of a business analyst? And the question is framed with respect to or with the perspective of pursuing an MBA analytics in the near future.
So I already discussed this thing. It is good to know coding. It is good to have a kind of mathematical background. But more important thing is that conceptual clarity part, whether you can think independently or not. You have to be an independent thinker, not that, I can beat the traded path. That's how I have scored good marks. Then that's not the right skill for data scientists. You have to formulate the problem. You have to tweak the algorithms by yourself and then generate the insights. That requires a lot of creativity, a lot of creative mind. So you have to be a thinker.
And the last question. So Geetika asks that if, as a fresher, she is going to be applying to data analytics in the industry. Okay. So what kind of things should she keep in mind before going for an interview, and what should she be prepared with?
First of all, are you acquainted with the algorithms, tools, and techniques? Because if I take the interview, I don't expect a fresher to know all the sophisticated things, but at least your fundamentals should be clear. That's what I expect. So if you have to clear the interview, don't think that I have to know all the things under the sun. No. You can very well say the interview, because interviewer knows. We know that you are, junior guys, you are just, the kids, you have just passed out the colleges. You are not supposed to know everything. But if you say that, sir or madam, I know this thing very well, so I will ask my questions on that, at least that part you know very well or not. So figure out your areas, focus on your area, and be thorough with your area. Don't try to beat all the things.
Right. So to end with, Ananya just has one request. She wants to just know the names of the competitions and the hackathons that you mentioned. So maybe she missed
You
it.
go to Kaggle. Kaggle is the platform, the kind of Kaggle, Kaggle.com. You can figure out.
Okay. So with that, we kind of have covered all the questions, and I would just like to take this opportunity to thank you, sir, for being with us, for making sure that the students are kind of well aware about things, because right now awareness is something that is more important as compared to anything else.
Sure.
And it's important for them to get this information at the right stage so that they can choose a career path accordingly. So
thank you so very much, Chintan.
Yes. Thank you so much, sir, for your time.
Thank you so much, everyone who are there today. Deeply appreciate your time.
Yes. And we put up the information about JAXOM in the chat, so you all can just check that in the chat.
Sure. Okay, guys. Bye.
Yeah. Thank you so much.
Thank you.